I run engineering and product for RDS MySQL and RDS MariaDB, and I'm joined by my colleague, Chayan, who's the lead product manager for both of these services. Welcome. Welcome to re:Invent. Thank you. Welcome to re:Invent. It's such an exciting time of the year for me, for all of us. You know, it's a great opportunity for us to connect with our customers and partners in person. It's also a chance for us to share what we've been up to through the entire year. Before I get started, perhaps a quick show of hands. How many of you use Amazon RDS today? OK, good number. And how many of you use either RDS MySQL or MariaDB? Terrific. Probably about a little bit more than half the audience. So for the benefit of those who are less familiar with RDS or just getting started on the AWS journey, Amazon RDS it's the portfolio of managed relational databases that we offer to our customers. We're very strong believers in customer choice, and so we offer you a range of options, all the way from commercial databases that are created by other vendors, you see that on the right of the screen, through to the most popular open source databases, MySQL, MariaDB, and Postgres. And also our own cloud-native database, which we call Amazon Aurora, which is MySQL and Postgres compatible. There's several talks this week that cover all aspects of the service. I highly encourage you to go to all of them, or as many as you can. But in this particular session, we're going to focus in on two of these engines, MySQL and MariaDB, which together, they represent the open source family of MySQL engines that Amazon RDS supports. I'm going to start with something fairly basic, which is why run MySQL? Now, I imagine most of you who signed up, also from sort of the question earlier, already use RDS, already use MySQL. So it must seem a little strange that for this audience, I'm starting there. The reason I'm doing it is there's been a ton of innovation, both in MySQL and also in MariaDB in the last year. And it continues to be a very strong choice for our customers. So I want to put a little bit of a spotlight on why do customers choose MySQL. Next, my colleague Chayan will talk about the benefits of running MySQL or MariaDB on RDS versus, say, on-premises, if you have any workloads running on-premises, or even self-managing it yourself on EC2. And he'll close with some of the tips and tricks that we have picked up, both from being amongst the largest MySQL fleet in the world, but also looking at our customers who are amongst the largest MySQL users in the world. So why MySQL? You know, it's really three things. The first, MySQL is the most popular database in the world, and MariaDB is not that far behind. The second, there's been a ton of innovation. If you look at the two new major releases that came out this year, MySQL 8, MariaDB 10.3, there's a lot to be excited about. Lots of cool stuff happening in the engines, in the ecosystem around it. And the third thing, it's open. So popular. That's kind of a weird thing, though, right? Why do I care about popular? You know, when I hear the word popular, I'm reminded of my favorite musical, Wicked. There's a song called Popular, right? The good witch is trying to make Elphaba popular. And it goes something like, it's not about aptitude, it's the way you're viewed. It's very shrewd to be very, very, very popular. Great lyrics, fantastic song, great insight into human psychology. But is that a good reason to pick a database, right? And it is. Popular, MySQL is the #1 used database, popular database, according to Stack Overflow. No surprises here. And MariaDB is not that far behind, right? What's interesting about MariaDB is it's actually been climbing the charts year on year. It's actually now ahead of Oracle. It's number 8 on the list. And if you look at just professional developers, the result's basically the same. And the reason this matters, the reason popular matters, is that you have the assurance that you have a ton of people pounding on the code, looking at it, using it in every possible workload that you may want to use it in. And as we all know, the best disinfectant is sunshine, right? When you have a lot of people looking at the code, a lot of people exercising all parts of it, you end up with highly exercised and stable code. So that's the first benefit of using MySQL or MariaDB. The second benefit is that there's a large ecosystem of tools, implementation providers, support providers that have grown up around MySQL. Just to use a few examples, a lot of our customers use Percona Toolkit, for example, for online schema changes. A lot of our customers use monitoring tools, right? We offer something called Performance Insights, but you can also pick Datadog, Vivid Cortex, Percona has its own thing. For most of the things that you want to do with a database, there is a readily available ecosystem. That's the second benefit of having something that's popular. And the third one is there's a large community of free resources that you can reach out to if you need help. And there's also a large talent pool, right? RDS is a managed database, but it's still very helpful to have people in your organization who understand databases well. Databases have a very large surface area, and so being able to access the talent pool is also very helpful. So that's popular. That's the first reason many customers continue to use MySQL. And it's sort of a self-feeding virtuous cycle. But popular does not really answer sort of the more fundamental question. Are these databases any good? Right? Or are these just emperors with no clothes? These are good databases. Like I mentioned, there's been a lot of innovation that's happened in the last few years. And MySQL and Maria spur each other to keep driving more and more innovation. And if you just look at the last year, MySQL 8.0, Maria 10.3, they both have a lot of very interesting features, and I'm going to dig into them. So let's start with MySQL. This is somewhat old news. MySQL 5.7 has been around for a while. But a lot of our customers are still migrating from 5.6 to 5.7, 5.6 to 8.0, which we just announced support for last month. And some of the big drivers for going to 5.7 from 5.6 are JSON. That's probably the biggest driver for using MySQL 5.7. But there's also things like spatial indexes. It's more of a niche feature, but for the folks that need it, super critical. When you look at 8.0, the cupboard is a lot more full. There's a lot of exciting functionality that's introduced in 8.0. There's a lot of interesting availability changes that have happened, performance changes, manageability, and security changes with MySQL 8.0. Just looking at the functionality, right? 5 features stand out, at least to me, and also when I talk to my customers. Very briefly, common table expressions and window functions make it simpler to write more complex queries. And in many ways, they sort of bridge some of the gap or narrow the gap to ANSI SQL and to Postgres. JSON does the same, right? It was introduced in 5.7. The team got a lot of feedback, and there's a lot of interesting new improvements to JSON functionality in MySQL 8. Beyond this, when you look at spatial indexes, which are again introduced in MySQL 5.7, there's a lot of new stuff under the covers in terms of more than 5,100 spatial reference systems. The way to think of a spatial reference system is it's a geometry, and you have built-in functions, for example, to do what's the distance between 2 points, right? So it makes it much, much easier to be a developer and use the database. And the last, this may seem like a small thing, but when I talk to customers in Asia and other places where Latin is not the default character set, it's a big deal, right? So to have default multi-byte character support. I'm going to dig into the first 3 because these are things that a lot of customers historically have looked at MySQL and said, hey, I'm missing this functionality. And now there's a lot of excitement around using MySQL because it's now possible. I'll start with common table expressions. So what are common table expressions? For those of you who are familiar with Redshift, Amazon Redshift, the data warehousing solution, or Postgres, which Redshift itself is built on, a common table expression is the with clause, right? It allows you to name a subquery and then use that name again in other parts of the query. So it's very convenient. It makes queries more readable, easier to write. You can chain them, and you can refer them multiple times. But perhaps most interesting, it actually improves performance, query performance. And it also allows you to do things much simpler, like recursive queries. So I'm going to dig into these last 2 points, right? And you can see the example here with the with clause. So why does it improve query performance? This is query 15 from TPCH benchmark, right? Nothing new here. You have a view which is revenue 0. You define it up front, and then you use it twice in the query, once in the from clause and once in the where clause, right? So this is standard MySQL before CTE for common table expressions. With common table expressions, the query largely looks the same. So this is not one of those cases where readability is fundamentally different. You put a with clause, you define revenue 0, and then you use it again twice in sort of the main query. So not that much difference. The difference is in how it's implemented. Without CTE, what's happening here is you materialize revenue zero, the view, twice, once for the from clause and once for the where clause. And what this means is you're doubling the storage, you're also consuming more time to generate those views, and you're also increasing the contention on the table on which that view is built, line item, right? So not the most optimal way to actually build this view. When you use CTEs or common table expressions, you only materialize the view once, and then you use it again how many ever times you actually use that view in the query, or use the common table expression. And if folks have run benchmarks on this exact query, and there's there's a 2x improvement in query performance time. So CTEs are not just convenient in terms of helping you express more complex queries, they can actually drive query performance. The other part, of course, is it does let you express more complex queries, right? Recursive queries are really hard to write in pre-CTEs. And this is one example of why you'd want to use a recursive query. So think of an example where you have sales data, and each row is how much you sold on a given date. And let's say I want to roll this up by date, and I want to be able to plot it. The way I'd want to generate this report is that every date should have some entry. Now, the problem with grouping query is that let's say that I have no sales on, in this example, October 2nd or October 6th, the ones with the pink arrows. You would effectively not have those results show up in a group by query, right? There's no entry for those dates. There's no group by to show up. And so you'd have to do some sort of a join with the original table to recover those data items, which is complex. With common table expressions, you can easily do a recursion where you generate all the dates in an interval. You can do a left join with the sales table, and then you can get the results you want. Right? This is one example of where you'd use a recursive query. And again, CTEs make it very easy to do that. Another example, perhaps a more classic example, is that you want to get the list of all the management chain in an organization. Here again, you can use CTE, right, with the with recursive clause. You can define a table where you start with the base case. Max here has no managers, so he's the top dog. And then you recurse through the table to get all the other reports, right? And you work your way through the organization. And then the query itself is very simple. You just select from the table, you order it by path, and that gives you the results that you see on the right. So common table expressions closes the gap to ANSI SQL, closes the gap to Postgres, more performant, very helpful in writing recursive queries and simplifying query design. I'll switch to the other big syntactic functional capability change in MySQL 8, and this is window functions. So the use case for window functions is you want to run an aggregation, but you want to do it in a way such that you don't lose record-level data. So let's look at the DMLs that you have on the top, the DDLs and DMLs. It's again a table. It's a sales data table. And each record has the employee, the date of the sale, and how much they sold. And we populated with some data for 2 employees, Otis and Max. If you wanted to find out how many sales, or how much the total sales was by employee, you can, of course, do a grouping. But in this case, you lose the record-level data. So Otis sold $600 of product in the period that's involved. Max sold 1,000, but it doesn't actually tell you what the individual sales were. If you want that finer granularity of detail, again, you'd have to do a self-join. You'd have to go back and recover sort of the original raw data, right? Perhaps you do it on, for example, on the employee name. But that, again, is complex. It's not very performant to go back and do a join. And this is where something like a window function can come in very handy. So what you see, again, in the purple is the over and partition by clause. For those of you who are familiar with Postgres, this will be very familiar syntax. This, again, simplifies the way you can do aggregates while retaining each row. And so you see the results on the right, on the bottom right, where, again, we have preserved every single row in the core table, but then the very right column tells you what the aggregation is. This is a bit of a dummy example. Something a little bit more advanced is if you want a running total. In this case, we order by date, and then we sum from the beginning of the table all the way through to the current row. And so now you see when you look at the result tables, again, you got the transactions or the records are ordered by date, and it's running total of the total amount of sales by both of those employees. An even fancier example, moving averages. In this one, we order and group by month, and then for any given month, we use the preceding and following clause to give you a moving average of a three-month window. So again, very powerful stuff, both CTEs and window functions in terms of the kinds of queries that you can now execute with MySQL 8. Let's go back to JSON, right? So JSON was the big news in 5.7, and there's been a tremendous amount of improvements in 8.0 versus what was previously available in 5.7. The first one I'd call out is JSON table, very powerful function to take a JSON object and convert it to a relational table. And when you do this, you can use a table anywhere else in your query, just like you would any other table. Very powerful. The next set of functions are the aggregation functions. In some ways, this is the inverse of the JSON table function, where you can take a table and you can collapse it, and you can create JSON objects for some fields. I'll give you a very specific example. So think again of a table where you got two columns. You got an employee, and then the second attribute is all the direct reports. If I want to create a new table that tells me, group this by employee and give me a list of the direct reports, you can use either the array function or the object function, the aggregation functions. And what it does is basically collapses all the employees, and it gives you a list of the people who report into them, right? There's other functions. I won't go through the full list. There's functions to merge objects. There's functions to simplify query syntax, and also utility functions, for example, for printing. So again, a lot of changes with JSON. So those were some examples of the very powerful new capabilities that MySQL 8 has from a functionality perspective, right? Something that makes your life as a developer much, much easier. But what if you're more on the operational side, right? DevOps or your database administrator? Does 8.0 actually add to the equation in terms of improved availability? Because in many ways, when you use a database for your production workload, perhaps the thing you care about the most is it never goes down, or if it does, it comes back quickly, right? And again, MySQL 8.0 has a lot of interesting new features that have come out. The three I'd call out are instant add column, unified data dictionary. Now, this may seem a little bit under the weeds, but I'll go into why this is important. And also very important, atomic and crash safe DDLs. I'll talk through each one of these in order. So the use case for instant add columns, right? Any one of you have large databases, millions of rows, billions of rows, you're used to this. DDLs take forever, right? And many of these DDLs, you got to go allocate temp space, you got to get locks on the table. It can run for hours depending on the size of your database, or the size of your table. And that's really painful. Degrades performance, creates contention, and as we'll see in a little bit, if you have a crash, you're sort of out of luck. Instant add column is just a fundamentally new way of looking at this. Rather than changing the data, it's basically just a metadata change. And you don't need to have a metadata lock when there's changes in the storage engine. And you don't go update the data itself. So things are basically instantaneous. There's a number of different types of DDLs, which you see sort of in the middle of the slide there, that you can now apply instant DDLs to. And the nifty thing about this is that if, for whatever reason, you can't actually execute a DDL using the instant algorithm, it fails fast and it fails explicitly, right? So you're aware of it. Very, very cool feature. A lot of customers want this, and it's now built into MySQL. The other thing I mentioned was a unified transactional data dictionary. Now, what is this? There's a lot of metadata that MySQL stores. The challenge historically has been that it's been stored in disparate places, and it's not transactional. So all of the asset properties, right, the commit, rollback, crash safe guarantees that you get on user data did not typically exist for metadata. And that's a dangerous thing, right? You don't want to end up with a corrupted table, a corrupted database. With this new improvement, there's now a unified data dictionary that's stored in InnoDB. The unified thing helps because it simplifies things like object caching. It, hopefully it'll improve sort of the rate of innovation. But the fact that it's InnoDB, the fact that it's transactional is critical because now you have very much the same guarantees that you would expect for any of your other data. And this is sort of the killer point here is that you now have atomic and crash safe DDLs, right? You're not going to end up with this inconsistent state if you crash at the wrong time. So that's on availability. Let's continue our tour. and turn to performance. Lots of changes under the covers to improve performance in MySQL 8. Specifically in InnoDB, they've done a lot of work to improve read-write performance and performance under contented workloads. In our benchmarks, and these are informal benchmarks, and even if they were not informal, I'd always say take benchmarks with a grain of salt, right? Your workload is different from our benchmark, and your mileage will vary. But we're seeing 2 to 5x improvements, performance improvement versus MySQL 5.7. A couple of other very interesting features. One is descending indexes. So what are descending indexes? Now, historically in MySQL, you could always traverse an index in the opposite direction of what was built. The issue was that there was a performance hit. With descending indexes, now you can traverse it in a forward direction, not pay the hit, and just as important, your optimizer can now use multi-column indexes, where the best scan method uses ascending in one direction, descending in the other. You're not forced to make the choice, right? So descending index is very powerful depending on your workload. The other nifty feature I'd say is invisible indexes. So in this, you can turn off an index so that your optimizer doesn't see it, and you see what it does to query performance. The important thing is you're doing this without actually in a non-destructive way, right? Your index still exists. Because if you actually had to delete an index and you realized, hey, I needed this index, that's a lot of work that you'd have to go back and recreate the index. So invisible indexes are great in terms of playing around and seeing what happens if I turn this index, what are the query plans, what's the performance like. And the inverse also holds. You can add an index in a staged way, and you can keep it hidden, and then you can make it visible when you know that it's actually helpful. So if you have multiple shards, for example, you can try it on some shards before you roll it out across the board. There's other very interesting changes under the hood with the cost optimizer. One example is that with MySQL 8, the cost model now is aware of how much of your index is in memory. Now, previously, it would assume that all of the pages were requiring an I/O, which is not always the case. So this is a much smarter cost optimizer. There's a few other things like resource groups, which I'll talk about in a second, but it allows you to assign threads to specific resources, so you have more control about kind of isolating your different workloads. And there's also a ton of improvements under the covers on replication. The chart that I showed before, we ran some basic, it's a custom benchmark that we ran just to kind of play around with MySQL 5.6, 5.7, and 8. The black line is 8 here, and it performs at 2 to 5x 5.7. Now, you'll actually notice that 5.7 has much worse performance than 5.6, but even so, 8 outperforms 5.6 by a healthy margin. I mentioned resource groups. It's an interesting feature. I think it's quite nifty. The idea here is that, let's say you have 2 types of workloads you're running on your database. One is a reporting workload, another is a batch workload, and you want to isolate them from one from the other. You can create 2 different resourcing groups for these, and you can say one set of vCPUs is assigned to one resource group, another set of vCPUs is assigned to another resource group, and then you can assign different threads to these resource groups. And what happens, if you look at sort of the bottom right, is let's say that at some point, you want to change the priority of, let's say, a reporting workload because you're running a huge batch job. You can reduce the number of vCPUs that you have assigned to that resource group. You can also turn down the priority, right? Higher is lower priority in this case. And that gives you a lot more fine-grained control over how your resources are being consumed across your different workloads. So that was in performance. Security and manageability are also obviously very critical for us, for you, for anyone that's running a real workload. And the key innovation here, I'd say, is around roles. There's also a few other things like password strength and observability. But the idea behind roles is that it's a named collection of privileges. Pretty basic idea, right? In this example that you see here, you could have an application where some set of folks have read access, some set of folks have read-write access. And what you could do is you could define these 2 different roles, read, read-write. You could give a set of database permissions into each role. And then as each user comes on board, you can decide which role you want to give them access to. Pretty fundamental, but makes access management a whole lot easier than it would be otherwise. So that's MySQL 8 in a nutshell, right? So there's a lot going on, lots of exciting new developments. from a performance standpoint, availability standpoint, functionality, security, manageability. And it's available on Amazon RDS as of last month. What about MariaDB? Again, 10.2 is relatively old, but I threw this up because it's sort of an interesting observation. A lot of the new features in MySQL 8 have also been in MariaDB 10.2, right? Common table expressions, window functions. It's really good to have these two different sort of vendors, communities, looking at each other, supporting each other to drive more innovation. Now, we also support MariaDB 10.3 as of last month. It's the latest major version. And MariaDB has its own set of priorities, right? I'd say the 4 major thrusts of their innovation are around Oracle compatibility, right? You'd expect MariaDB to do this and not MySQL. And it's great that MariaDB is focusing on giving customers who are currently in Oracle an open source alternative. There's a lot that drives this. There's stuff around the parser, stuff around new functions, data types, and I'll go through some of them. The other thing they've done that I think is very interesting is what they call temporal databases. It's a new construct where essentially they maintain version tables, and you can ask a query as of a historical time. And I'll give you some examples of that as well. They've also introduced user-defined aggregates, and just like MySQL 8, they also have add instant column. So let's dig into the Oracle compatibility. So the big addition with MariaDB 10.3 is this new SQL mode that they call Oracle, right? You can set the compatibility mode of MariaDB to be SQL mode equals Oracle. And what happens when you do this is that it's able to understand PL SQL language, right, syntax, without having you change it to MariaDB's native stored procedure language. And this is huge. All you have to do is set the SQL mode, and the parser automatically addresses a large subset of the syntax for PLSQL, so you don't have to go change your stored procedure code for it to run on MariaDB. And you can see sort of the examples of things that they handle here, right? It's a very comprehensive list. And you can have both stored procedures in the PL SQL syntax and also MariaDB's native syntax interoperate with each other, right? So you don't have to choose between one or the other. The other set of changes that MariaDB continues to make as it strives for more and more Oracle compatibility is things around more data types, right? So they've introduced sequences. The best way to think about sequences is it's auto increment plus plus, right? It, again, works along with auto increment. You don't have to make any changes to your existing tools or processes. They've also introduced a new data type called row, which is, think of it as a vector, right? It's basically a tuple. And you can use it anywhere that you could use a normal variable, anywhere where a stored procedure variable would show up. And they've also been adding functions. Some of these may seem small, but they're again important if you're moving off of Oracle and onto an open source engine, right? So this example is for intersect and difference. It does what you'd expect. The syntax is pretty straightforward. One other thing that they have done in terms of driving greater compatibility with Oracle is they've introduced invisible columns. It's a little similar to invisible indexes. You can add columns to a table, and you can mark it invisible. And what this really does is it makes it optional for applications to use them or not use them. So it's a really good way to evolve your database without breaking your existing apps. It's also a really good way to deprecate columns that your new applications may not require, but your existing applications do, right? So it's a great sort of feature to be able to prepare your database for an upgrade, for a schema upgrade, before you actually have to go do anything with your applications. The last thing I'll point out with Oracle compatibility is the changes they've made to their cursors. Here, they've essentially made cursors take in parameters. So the example you have here is you have a table T1, and there's a cursor, there's a stored procedure called P1. Now, the goal of this is that you're able to pass in an interval into the stored procedure, right, which is the min and the max, the two arguments, which then get pushed down through the cursor so that when you're actually fetching SQL results, that filtering is happening for you automatically. And again, that aids with Oracle compatibility. The other very interesting feature in MariaDB, as I mentioned, was temporal databases. The idea here is that you can mark a table as a system version table. And when this happens, it effectively maintains all the history of all the changes that have happened to that database. Everything is timestamped. And you can use the as-of syntax, which you can see some examples on the slide here, to ask a query as of a certain time or as of a certain interval. And this is, again, very helpful in terms of data analysis, right? You want to go back, retrospect on trends. Very important in terms of forensics. Maybe something went wrong or you had a data change that you're not expecting, so it's a good way to audit and look at lineage of data. It's also a neat way to do point-in-time restore. So this is the other big feature in MariaDB 10.3. And again, MariaDB 10.3 is now available on Amazon RDS. So clearly, there's a lot going on with both MySQL and with MariaDB in terms of innovation, right? The third big reason is both of these engines are open. And this matters to a lot of customers, right? Customers have suffered with lock-in. Just last year, one of the two commercial vendors that I showed on an earlier slide, just overnight, they doubled the cost of using their commercial database on AWS. I mean, who does this to their customers, right? I mean, someone who's much more focused on driving finances rather than obsessed about their customers' success. And so for folks who are being burnt this way, or folks who are afraid of being burnt this way, open matters. Sort of reminded of the song by George Michael, right? I don't belong to you, you don't belong to me. It's very liberating. Every day, we want customers to choose these open source engines or choose RDS because we've earned your trust, we're the best solution for you, not because you're locked into us. So with that, I'll hand it off to Chayan, who will walk through the benefits of Amazon RDS.
Thank you, Shirish. All right, hello, everyone. So in the previous segment, Shirish, what he really showed you was how, when you consider database options, MySQL databases stand out. So they have been battle tested for close to 2 decades now on workloads which are as critical as you can imagine. Right? And with recent innovations in 10.3, MariaDB 10.3, MySQL 8.0, it's also becoming increasingly easier for you to migrate from, let's say, commercial databases to MySQL databases. Recent innovations in form of deeper JSON integration, geospatial functions also position MySQL databases really well for modern app development. Right? So as Shirish ended with the reason behind using MySQL databases, and for that matter, any open source database, is that you can operate it wherever you like. Right? You have the flexibility of running your databases on premises, on EC2 if you self-manage them, or run them on RDS. Right? So in the next segment, what I'm going to focus on is the reasons, essentially, why RDS MySQL makes sense for you, how RDS can help you run your MySQL databases better and help you improve your productivity, do more with your resources. And the premise for that is really straightforward. With RDS, we do the heavy lifting for you. And by heavy lifting, what do I mean? It's stuff like backups, patching, monitoring, replication, high availability. These are things that you have to think about, manage yourself, worry about, right? And at onset, it might seem simple to operate. But over time, customers tell us that these become really cumbersome. So we do this heavy lifting for you so that you get the time to focus on what really matters for your business. So think of if you are an application developer, right? What do you want to do? You want to build awesome apps for your customers, right? If you are a database administrator, you want to spend time with your development teams, make them more productive, help them improve their queries, design schema with them. Right? So with that premise, what I'm going to focus on is a set of 3 reasons, same 3 reasons why you should be using MySQL databases for. Those reasons why you should be using RDS MySQL databases for. Right? And I'll start off with popular. Right? So a little bit of context here. Back in 2009, when RDS was launched on AWS, it was one of the first services. And it was built on a core principle to help our customers. By then, we had developed over a decade of experience running databases for world's largest e-commerce website, right, Amazon.com. And we thought, how could we take these lessons that we have learned and use it to help customers run their databases, AWS customers run their databases better. So that's how RDS came into being. And since then, we have covered a lot of ground. Now, hundreds of thousands of customers use RDS for their databases. And you can imagine like any industry vertical, and we have customers from those verticals using RDS. So think about internet scale companies like Netflix or Airbnb, pharma companies such as Bristol Myers Squibb and Merck. And then we have manufacturing companies, GE, using RDS. So what do we get with this, right, with this popularity? The fact is that we are likely running one of the largest MySQL fleets in the world, right? No one individually can cover the service area that we come across, which means our code gets exercised very heavily. We fine-tune it, we hone it. Our tools are purpose-built for what you can do in the cloud. It also means that our operators who are looking at all these issues at that scale are engaging very closely with our customers, developing solutions for that. Right? Think of a security patch maybe, or maybe an OS issue. Right? And as we discover these issues, we go back. We have a really phenomenal world-class team of engineers who go back and automate this. Right? So I see this as a virtuous cycle. The more databases that run on RDS, the more surface area our team covers. The more lessons we learn, the more tools we build, and we put it back into the system. Right? So it becomes better and better over time. One example of this is recommendations. Right? So it's not just limited to automation. As our operators learn more about running databases at scale, we take those experiences and share them with you as best practices. So RDS recommendations is a feature we launched in the last year, and I'll touch upon that more. Essentially shares these best practices in an easily consumable way to you on the console. So with that squared away, I want to focus on the innovation and the stuff that we have done to make it easier for you to run your databases on RDS. Right? And the first point there is automated zero recovery point failover across availability zones. Right, so let me clarify a little bit there. What it implies is our multi-availability zone or multi-AZ deployment scheme. Now, an availability zone in AWS speak is essentially a fault-isolated data center. Right? So we synchronously manage a standby for your database in another availability zone in order for your applications to tolerate failures. And the failover between the standby and the primary is managed by us. It's automated. So it's transparent for your applications. The other great piece of functionality that we offer is read replicas, and read replicas across regions. AWS operates across the globe, multiple regions, right? So previously it was unfathomable for most companies of most scale, right, to deploy data centers in 14, 15 countries. Impossible. With AWS, it's straightforward and simple for you, right? It's a click of a button, and you can create a read replica in another region, AWS region. Some of the reasons why customers create these read replicas are to offload, read pressure from your primary database, you can do that. You can use it for read scaling or serving reads closer to your end customers. And finally, of course, right, it's a critical tool. I'm not sure if we'll ever lose a region, but if that ever happens, you can use these read replicas for disaster recovery as well. And then we offer automated backups. Backups are taken continuously for you every 5-minute interval, which means we can give you capabilities like point-in-time recovery. So within your backup retention window, you can flip back your database to any point in time with a granularity of 5 minutes. And on top of it, you also have the option of creating manual snapshots, right? A point-in-time snapshot of your database, which you can keep for your record keeping, or if you want to use it for disaster recovery, you can copy it to another region, or for your confidence at the very least. Another thing that we added support for in the last year, which is new, is that now we allow you to scale up your database up to 32 terabytes. And this scale is elastic. That is, you can do it online. You can change the size of your database if your database is full. Like, there's no point if your database gets full, you're not available anymore, right? So you want to maintain availability even when you're going to hit the limits of storage in your database. So we allow you to seamlessly, with the console or APIs, you can just add additional storage up to 32 terabytes it's supported. So with that, I do want to double click on the availability pieces in terms of multi-AZ deployment, particularly because just because this option is there, it doesn't mean that your app is designed or configured to run with this configuration in a seamless manner, right? So to give you a little bit more detail into how multi-AZ setup is configured for you, right? So you essentially get one instance when you create a multi-AZ database instance in RDS. But under the covers, there's a standby instance available, running in another availability zone. And the data between the primary and the standby is replicated synchronously at the block storage level. As you can see in the diagram, the storage volume is where we are copying the bits and bytes off to the standby. So which means it's not logical, it's a physical replication. And monitoring all this is an RDS, third party essentially as an observer to ensure that there's no confusion as to who the primary is and who the secondary is or the standby is. The other key important function that observer does is that whenever, let's say, there's some sort of unavailability in the primary, whether there's a network outage, you have a bad host, something going on in that availability zone, RDS process would automatically detect that and fail over to your standby. And here's where I want you to also go and ensure that you test this failover, right? You can also initiate this failover through the console or through the APIs. And with that, what you want to make sure is that your app using TTL, time to live values, for the DNS endpointed setting, small enough that when the failover happens, you get back the IP address of the now promoted standby, right? You want to be able to connect to that standby. Your old connections, of course, would break, so your app would hopefully retry, and when it's retrying, make sure that the TTL values are small enough, you get the new IP address. Once that happens, of course, your app reconnects to the new primary, and under the covers, RDS flips the standby for you. Right now, we create a new, we flip the role of the old primary into standby and reestablish replication, which means you continue to have a high availability configuration. The other aspect I want to talk about in terms of availability and dive deeper into is how you manage backups and snapshots on how you can do point-in-time recovery from those snapshots. So as I mentioned previously, you have an option of automated backups, right? And these backups are by default retained for you up to 7 days. And what we essentially do with automated backups is that every day around evening, that's when we take a full snapshot of your database. And every 5 minutes, we take this transaction logs and we ship it out to S3 for retention. So whenever you are doing a point-in-time recovery, we find the nearest snapshot that we have, replay back the transaction logs, and you have your database pointing to a state in the past. One key benefit, sort of tying back to multi-AZ deployment, is that backups and snapshots have no impact on the performance of your database. And you ask why? That's because backups are taken from the block storage device in the standby. Right? So your primary remains fully available to serve your application workloads. So that's another reason you may want to use multi-AZ deployments. The other piece I wanted to talk about is, of course, manual snapshots. Right? So you also have the option of, on the console or through APIs, take a point-in-time view of your database and store that. For many times, customers do that for their own confidence. Sometimes they do it for compliance reasons. They might need to go back to an old state at some point. Another interesting reason I have seen customers use them for is disaster recovery. So you can copy it over to another region, and for whatever reason, if your primary database becomes unavailable, you can use that snapshot to restore your database. Snapshots can also be shared with other accounts, right? So this I've seen being used for situations where you have a separate dev test AWS account. You want to use the most recent production database, but of course don't want to impact it and want to perform maybe DML or DDL operations. You restore a snapshot in another account, do all the tests you want to do there, and eventually make that change on your production account. Moving on to security and manageability. Again, many options that we offer and many switches and knobs that you can use. One key thing, fundamental thing is, from ground up, RDS is designed to be secure. It uses the same schemes that you apply in EC2. You get your VPC, virtual private cloud. You get your own network isolation there, right? One best practice I want to share here is that when you are setting that up, make sure that you are not opening up your production databases for public access. You only want your regular applications to be talking to your database, production database. Another key capability here is IAM database authentication. IAM, or Identity and Access Management, is a service that you use to control and grant access to resources within AWS. And much like you use IAM users and roles within your AWS account, you can use that to also manage permissions within your database. That's what you get with this. So it becomes simpler for you to sort of manage authentication into your database with that. Many customers are concerned about compliance. So we are compliant with FedRAMP, HIPAA, many other regulations if you want to look at. And then coming to scaling, both instances, and as I mentioned, storage, compute scaling and storage scaling, you can do it with a push of a button. Similarly, managed bin log replication, we manage it for you. Recommendations, I already touched upon it briefly. Essentially, we share best practices with you. And the final thing that we added, I want to talk about in the last year, is log upload to CloudWatch logs, right? So audit, general, slow query, and error logs. Oftentimes, customers want to retain them for longer durations. So now you can stream them out to CloudWatch and retain them for whatever duration you want. With recommendations, as I was saying, we are really taking the best practices we observe and share it with you. It could be that your database is not encrypted. Maybe you are running an outdated configuration. So you can use the notifications you receive on the recommendations console, so the RDS console, and act on it. You can schedule any remediations for the next maintenance window or immediately. So it's just a point-and-click operation again. On the performance front, we added the latest generation of instances. M5 instances are general purpose instances. R5 instances are coming soon for MySQL and MariaDB. The other piece is performance insights. With performance insights, you, of course, can dive deeper into your database, really see what's going on, right? What queries are running, what queries are taking the longest amount of time, which hosts are throwing, what kind of workload. If there's some sort of DDoS happening there, you can view that through a really nice dashboard. Similarly, you can find out where contention is going on in your database, right? Which queries are ill-performing. Data is retained for you for free for up to 7 days. Beyond that, also for a small fee, you can retain all this information. And with that, the next thing I want to focus on is openness. Right? Much the same way you can import data into RDS, right? We provide tools for that. Data migration service is a service you can use to migrate data into RDS from various different sources that are listed there. I would encourage you to use this service in situations where you are doing heterogeneous migrations. And what that means is, let's say you're migrating from a non-MySQL compliant database. It could be SQL Server, Oracle, whatever. If you're doing homogeneous migrations, that is migration from a MySQL source, you're better off relying potentially on the native MySQL tooling, right? So MySQL dumper and loader. Also, you could use Percona ExtraDB backup third-party tools like that. And as easy it is for you to get data into RDS, we also make it easy for you to take the data out, right? So you can use DMS or the MySQL tooling to take your data out to all the different systems I mentioned there. So again, pointing back to George Michael, right? I don't belong to you, you don't belong to me for whatever reason. If you don't like RDS, you have the option of going out and taking your data out if you want to. With that, what I want to move on is hopefully I've convinced those of you who are not already running your MySQL databases on RDS to do so now. And one of my favorite things as a product manager is the interaction I have with customers, understanding their problems and giving them solutions. And oftentimes, these solutions are not about building new features. It's about providing guidance on what already exists. Right? So I'm going to touch upon very quickly upon 6 frequently asked questions that we often get. I'll start off with the first question. If you're coming to RDS new, or if you're already running your databases, is like, what instance, what type of instance should I be using, right? So we offer 3 broad families of instances, and it has grown over the last year, right? So we offer T3s now. When you think about T2 and T3 instances, these are burstable family of instances. What it means that you get a certain set of CPU credits, which you can monitor through CloudWatch, and those credits you can consume bursting, right? You also get moderate networking with that. We typically recommend using these instances for dev test workloads. You also get access to free tier with T2 and T3 instances. So you can run a T2 micro instance or T3 micro instance for a year and try out RDS and see how it works for you. M family of instances, of which now we support M5, are general purpose instances and really meant for compute intensive workloads, right? So if you're doing heavy writes, these instances are great for that. With M5, you can now go up to 96 vCPUs and 384 gigs of RAM, right? So that's tremendous, that's amazing. The next family is the R family, which is memory optimized. You get twice the memory per vCPU, right? And with R5, we'll add support for that soon. You will get, again, 96 vCPUs, but 768 gigs of RAM, right? So if you have a workload which needs a very large working set in the memory, these are the instances for you, right? It's tremendous, like close to 3/4 of a terabyte you can store in memory. So use that for query-intensive workloads where you need that kind of memory footprint. The other question I get is, like, when should I use multi-AZ versus read replicas? And my simplest answer is it's not either or, right? it probably makes sense for you to use both. Multi-easy is great for maintaining high availability. We are, of course, doing synchronous replication there. But the point to note there is your standby is not available for reads. Only the primary instance is available for reads. Whereas with a read replica, it's more general purpose. The replication is asynchronous, you must note here, which means that depending on your workload and depending on where your read replica is, I mentioned that your read replica could be in another region, it could be in another AZ, it could, for that matter, be in the same AZ. But depending on replication lag, how further behind it is from the primary, you could lose some data if you happen to fail over. But it's great for situations where you want to offload read pressure from your primary, or you want to use it for serving reads closer to your end customers or disaster recovery. Right? Another key thing to note here is that engine version upgrades happen independently with read replicas. That is, you can upgrade your read replica first, see if it works fine with your application. If it does, test it out, then you can upgrade your primary as well and be satisfied that it works fine. With multi-AZ, the failover is automatic, as I was mentioning. Right? We detect and we failover, we manage it for you. Read replicas, it's manual, so you have to make the choice. If you do want to failover, you can go in and do a manual promotion, especially if you're doing it for disaster recovery. It might make sense for you to do that anyways, right? Again, automated backups and manual snapshots. Automated backups are great. Turn it on, keep it for a duration that you prefer to have the ability to go back in time, right? In terms of operational pain, right? So if you think that 7 days are fine, that's the default. Go with that. You can go up to 35 days. A new capability that we introduced very recently is the ability to retain automated backups even after your instance is deleted. What that means is that by mistake, if you delete your instance, you can still perform point-in-time recovery with your automated backups within the retention window. So if you have configured 7 days, up to 7 days, you can go back and get your instance back, data back. Manual snapshots, they're retained for however long you want. Also used for compliance purposes, disaster recovery purposes. Another option, question that I often get with customers is, how do I secure my database? So I talked about VPC. You have access to security groups. Consider them as your firewall rules, or make sure that only authorized instances are accessing your database, right? I have touched upon that with KMS. Key management service, what you can do is you can either bring in your own keys, or you can use KMS to generate encryption keys and encrypt all the data at rest. And finally, of course, SSL is used for encryption for anything that goes over the wire. Monitoring databases is, again, a very key aspect. If you're running databases, you also want to know what's going on in your databases. So CloudWatch metrics, enhanced monitoring, make sure you have turned that on. You get up to more than 50 metrics emitted to CloudWatch. CloudWatch logs, I touched upon this briefly. Once you have these audit logs, general logs in CloudWatch, you can also set a monitoring on top of it, right? So you can say that user X should never have access to table Y, and if that ever happens, tell me, right? So you can set up things like that. Alarming is similar to, again, I talked about it, monitoring tools. Other capabilities, performance insights, also gives you APIs, right? So if you're used to using third-party tools on premises, you can use those tools to ingest the data from performance insights and get visibility into your cloud infrastructure. Another new capability we added is with RDS events. RDS events are special types of events that are published on an SNS topic, on which you can, of course, set up email, text, alerts. What we are now also doing is we are emitting this out to CloudWatch events. So now you can use CloudWatch events and programmatically react to things happening in your database, things like storage full or backup failure, right? Backup was not taken properly. And CloudWatch events makes it really easy for you to point it to a Lambda function or an ECS for automation on top of that. Few things that I really want to talk to you about, a few other sessions. We have a lot of great stuff packed into the week. These 3 sessions, Amazon Aurora, as Suresh mentioned, it's our database built for the cloud. If you want to learn more and what we have done in the recent past, do attend that session. It's today. And then migrations, we talked about data migration service. There's a topic on that too. And finally, what's new in broader relational database service space as well. So with that, thank you very much. Thank you for joining us today.